If you thought that Mercury was much too close to the Sun and too hot for life to exist, we have exciting news for you. A research team has now discovered something on the small planet that no one would have thought possible before. According to their findings, there could actually be salty glaciers on Mercury, and thus an environment that serves as a home for extraterrestrial life forms. Many think that it would be simply impossible for organisms to survive under such extreme conditions. But they thought wrong, because in fact, on Earth we also know living creatures that successfully defy such adversity. So be sure to stay tuned until the end if you want to know how life could have developed in the hidden glacier world of Mercury. With a diameter of 4,880 kilometers, Mercury is not only the smallest, densest, and oldest planet in the solar system, but also one of the most enigmatic. The fact that this compact celestial body, which in its appearance is more reminiscent of a moon than of a classical planet, still hides many of its secrets is mainly due to its location. Since Mercury is the planet in our solar system that is closest to the Sun, the blazing light of our host star makes direct observations from Earth almost impossible. In the same breath, however, the associated deadly radiation also makes any thought of a manned mission to Mercury impossible. But luckily, there are still unmanned probes. Well, at least in theory. But in practice, Mercury has so far only been visited by 2 spacecraft and examined up close. The first of these was NASA's Mariner 10 probe, which made its first flyby of the planetary pipsqueak in March 1974, followed by 2 more passes a little later. During the course of these, the earthly guest took more than 4,000 pictures of Mercury, capturing almost 50% of its surface. NASA also sent a second visitor to Mercury by the name of Messenger. The probe orbited the planet from 2011 to 2015 before making a crash landing on its surface. That was planned, but ultimately unsuccessful. Before this dramatic exit, however, Messenger's instruments provided a wealth of valuable new information, such as the traces of massive volcanic eruptions, mysterious depressions in the crater landscape, and indications that Mercury has a different chemical composition than Earth or the Moon. Furthermore, Messenger also provided the explanation for unusual scarps on the planet's surface, which are hundreds of kilometers long. These were actually formed because the planet has shrunk since its early days. Soon after, another exciting discovery made astronomical headlines. Although Mercury is, on average, only 58 million kilometers from the Sun, and the temperatures on its day side therefore rise to 430 degrees Celsius, there is water ice in some of its craters. Another Mercury mystery that was solved with the help of Messenger concerned the planet's surface, which appears much darker than it should. The experts found that this could be due to extensive bombardment by carbonaceous micrometeorites. After all, the dark dust from these impacts would literally color the celestial body, and thus also reduce its reflectivity. However, the object to which Mercury probably owes its exceptionally large iron core was much more impressive than the micrometeorites, because it could result from a collision with a larger protoplanet. A sparkling secret. Does Mercury hide a diamond treasure? As we can see, a close-up examination of a planet always has the potential to provide groundbreaking new insights into the celestial body of our desire. And the good news is that the next Mercury mission is already on the starting blocks. Developed as part of a collaboration between the ESA and the Japanese space agency JAXA, the Bepi-Colombo spacecraft left Earth on October 20th, 2018, and has performed several swingbys of Mercury since 2021. If all goes according to plan, it will swing into orbit around Mercury in November 2026 and once again take our knowledge of the planetary dwarf to a whole new level. And who knows, maybe Bepi-Colombo will then confirm the existence of what is probably the wildest dream of every jeweler. Because it could actually be that deep inside the planet, a layer of pure diamond glistens away. And just so we understand each other, we are not talking about a delicate gemstone coating here, but a sparkling region up to 18 kilometers thick. But what was the reason for this exciting assumption in the first place? Well, researchers point to the fact that Mercury's crust and interior contain 1 to 2% carbon in the form of graphite. In this regard, The experts have used high-pressure experiments and models to investigate whether the carbon remained as graphite at the core mantle boundary of the young planet, or whether the pressure was high enough to compress it into diamond. In contrast to studies in the past, however, the scientists added another ingredient to the early mercury recipe: sulfur, which we now know also occurs in abundance on the small planet. And lo and behold, with a sulfur content of around 11%, the temperatures and high pressure at the bottom of the primordial magma ocean are enough to transform a small portion of the carbon into diamonds. While this sparkling layer is only between 0.1 and 200 meters thick, it could have been significantly strengthened by the core diamonds. Since these diamond crystals were lighter than the remaining molten metal, they rose to the core mantle boundary, where they deposited and formed a diamond layer that could be about 15 to 18 kilometers thick today. Unfortunately, since the gigantic gemstone deposit would then be hidden more than 600 kilometers below the surface, it would be impossible to detect it from the outside or by indirect measurements. Nevertheless, experts believe that it's conceivable that at least some diamonds were brought to the surface by circulation currents in the early days of the planet, volcanism, or large impacts. And if this is really the case, the so-called high magnesium province is considered the most promising candidate for a diamond strike. The unusually high magnesium content detected here is thought to indicate that material from greater depths was transported to the surface there. And Bepi Colombo is to check in the future whether diamonds were among them. A groundbreaking discovery. Is there life on Mercury? The discovery of a kilometer-thick layer of diamonds on Mercury would undoubtedly be sensational. But let's be honest, what would it be compared to the realization that the small planet also harbors extraterrestrial life forms? Basically, the celestial body has been rather uninteresting for the search for possible life so far, and that is anything but surprising. As already mentioned, the thermometer on its day side not only climbs to 430 degrees Celsius, but simultaneously falls to a bone-chilling 175 degrees below zero on the night side. Added to this is the fact that Mercury has practically no atmosphere, which means that the sun's radiation hits the planet's surface virtually unfiltered. But despite all this, and this is the exciting thing, life on Mercury could now have taken a turn for the better. After all, Alexis Rodriguez, the lead author of the corresponding study, which appeared in the Planetary Science Journal, points out that Mercury and our Earth could be much more similar in one respect than previously thought. But what does that mean? Well, basically, Rodriguez's team has found that Mercury most likely also has glaciers. However, these are structures that differ significantly from their terrestrial namesakes. What are still massive ice masses with clearly defined catchment areas on Earth are salt flows on Mercury that have trapped volatile compounds such as water, carbon dioxide, and nitrogen deep below the planet's surface. These saline ice flows were, in turn, exposed by asteroid impacts. And the crucial clue to their existence was hidden in the messenger data, which had revealed areas with elevated concentrations of volatile elements. At the same time, however, some telltale pits and pockmarked landscape formations also suggest that substances have once outgassed and sublimated there. Rodriguez says, "Our results complement other recent research showing that there are nitrogen glaciers on Pluto, meaning the phenomenon of glaciation extends from the hottest to the coldest areas of our solar system. The Mercury glaciers originate from deeply buried volatile layers exposed by asteroid impacts. Our models strongly confirm that these glaciers were likely formed by salt flow, and that they continued to contain volatiles for more than 1 billion years after their emplacement." Rodriguez also emphasizes that sites like this are of central importance for science. But what does that mean in concrete terms? Or, to put another way, what does the discovery of the salt glaciers mean for the possible existence of life on Mercury? Well, that becomes clear to us when we draw a line back to Earth at this point. Because even in the most extreme regions of our home planet, such as the Chilean Atacama Desert, there are habitable zones that are only made possible by special salt compounds. And against this background, Rodriguez classifies the situation on Mercury as follows. This makes us wonder if there are subsurface terrains on Mercury that might be more hospitable than its harsh surface. This groundbreaking discovery of Mercury's glaciers broadens our understanding of environmental parameters that could sustain life and adds an important dimension to our research in astrobiology. And for good reason. After all, other planets similar to Mercury could also have comparable mechanisms, and thus pave the way for potential underground life.